Now let's spend a few minutes and talk about ions, electrolytes, and free radicals. So the definition of an ion is a charged particle. Either it could be an atom or it could be an actual molecule. And in this case, we have and this is an important word, I'm going to underline it. We have an unequal number of protons and electrons. Now, there's also a word, ionization, which means the movement or transfer of electrons from one atom to the other. And do they do it? Yes, they do. Okay. An anion is the atom that gains electrons. So remember, electrons have a negative charge. So if you gain an extra electron, you become more negative by gaining that electron. And then we also have cations, and that's the particle that loses an electron. And once again, what's the charge on electrons? They're negative, right? So if I lose one of my negative charges, then the overall net effect is now I become more positive. So we're looking at them becoming more positive. And the other thing is that ions with opposite charges tend to attract each other. So some with a positive charge, one with a negative charge, they tend to want to congregate together. Now there are some cases of ionization, and let's have a look here. Here we're looking at sodium, and we're looking at a chlorine right here. And you can see there's a nucleus with the protons and the neutrons within it, and we're not going to get too hung up, but sodium has, 10, in this case 10 protons, 12 neutrons, 11 over here. Chlorine has 17, 18, and 17. We're not going to remember those numbers, but you can go through and have a look. Now remember, what I said in one of the earlier videos is that we have these concentric clouds. Almost, I like to think of it as the layers of an onion. It looks like it's two-dimensional here, but think three-dimensional. And these different layers, or shells, that's the space that electrons will inhabit. And there's certain rules around how many electrons are in a given shell. Like the first shell, you see 1, 2. Now once you have both of those, then basically what happens is that shell is full. The first shell fills really easy. And then any extra electrons end up in the next shell. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the next one can hold up to 8 electrons. Now, if there's any other extra electrons, then they go into the outer shell. The outer shell is created, and here it is, right there. So here we have pure sodium. Here's pure sodium right here, right? And it has just 1 electron hanging out there in its outer shell. And then we have over here, it's good buddy chlorine right here. Once again, this shell is full, this shell is full. And then out here it has 1, 2, 3, 4, 5, 6, 7. It has 7 in its outer shell. Okay, so now we have this case where we have, let me just change color here, where we have sodium with just 1 electron in its outer shell. So there's only 1 electron in its outer shell. Here, with chlorine, there are 7 in the outer shell. Now, I think I gave you the warning. This is a biologist's view of chemistry. The way I look at it is I sort of picture it that these atoms want to sort of be in a Zen-like state. They want to be in like atomic nirvana. And the way they achieve that is by filling their outer shell. Now, if you think about poor sodium right here, it only has 1 electron in its outer shell. Now, if it wanted to sort of fulfill that desire to have a full outer shell, well, then it would have to go around and basically beg, borrow, steal 7 electrons to try and fill its shell. That's a lot of work. That's just way too much work. I think we can do better than that. So we have this issue where sodium has 1 in its outer shell. It needs 7 to kind of fill its outer shell. That's a lot of work. And then it's got its good buddy over here, chlorine, who actually has 7 in the outer shell. It only needs 1. It only needs 1 to fill it. And this is like a match made in heaven. I imagine they're walking down the street towards each other. Sodium's coming down one sidewalk, all kind of bummed out that day. Chlorine's coming the other direction, all bummed out. They meet each other, and sodium's going, oh man, I got this, my outer shell isn't full. Oh, I got 1 electron, I don't know what to do with it, And there's chlorine going, yeah, I can kind of appreciate that. I got 7, and I'm short 1. And then the light bulb goes off. And what the light bulb is, of course, you already know this, I think, is that sodium takes its 1 electron and gives it over to the chlorine. Now, you're asking what happens to this outer shell? Once this electron's gone, this outer shell just magically, in our world as biologists looking at chemistry, just disappears, okay? But what we've done here is we've now given chlorine its full outer shell. So now it has 8 instead of 7. And over here on sodium, its problem has now been rectified. It's given up an electron. This outer shell has magically disappeared, and now the shell that's on the outside has the right number. So everyone's happy, and we can see that down here. We can see what's happened down here is that the outer shell has disappeared, and now I have 1, 2, let me do this. Change pens. 1, 2, 3, 4, 5, 6, 7, 8. Is it happy? It's happy. Okay. And over here, you can see that we've gained an electron, and it has 1, 2, 3, 4, 5, 6, 7, 8. So it is happy. Everyone's happy. This is a good little story right here. Now, but you can see one of the effects of this is because this atom has lost an electron, which is negative. It now has a positive charge. Because if you lose some of your negativity, you're going to become more positive, just like people, maybe. And then we have chloride, which has gained an electron, which is negative. So now it has an overall more negative charge. Now this is great, because remember what we just said before? When you have positives and negatives, they like to attract each other, which is not surprising why sodium chloride is a fabulous little molecule, because sodium and chloride love to get together because of the positive and the negative shift. So that is a little bit on ionization. Okay, I think we're just going to make this just a little mini video, so we're going to stop there and then we'll move on to the next one.